Welcome to the Elon Musk Signal channel. In recent years, SpaceX has been consistently launching Falcon 9 and Falcon Heavy rockets, contributing significantly to the payloads sent into space. While Falcon 9 usually transports Starlink satellites or participates in shared ride missions, Falcon Heavy is tasked with breakthrough missions. Its payloads often include large spacecraft and billion-dollar scientific experiments. Therefore, it can be said that although Falcon Heavy is not launched as frequently as Falcon 9, it undertakes the most valuable contract. In this video, let's explore the special mission of the Europa Clipper and how SpaceX will conquer space with its giant rocket. In just a few months, in October of this year, the heavy-lift rocket Falcon Heavy will undertake a historic mission, launching the $5 billion Europa Clipper spacecraft of NASA into orbit around Jupiter's moon. On June 4th, NASA officially unveiled the Europa Clipper, marking a significant milestone in preparing for the exploration of Jupiter's moon Europa. Launched from Launch Complex 39A at Kennedy Space Center by the Falcon Heavy rocket, the Europa Clipper could rival the James Webb Space Telescope in cost and development time. Since 2013, the Europa Clipper research program has cost up to $5 billion, not including the expenses for the nearly 5-year journey to Jupiter. This is a gigantic space science project with ambitions to search for extraterrestrial life. The main mission of Europa Clipper is detailed survey of the Europa moon's surface. Europa Clipper will be equipped with state-of-the-art scientific instruments to conduct comprehensive research on the icy surface of Europa. Search for conditions suitable for life. Scientists are particularly interested in whether the subsurface ocean beneath Europa's ice layer is conducive to supporting life. Europa Clipper will analyze the composition of Europa's surface, search for signs of recent geological activity, and measure the thickness of the ice layer. First-ever exploration of the subsurface ocean. Europa Clipper will use advanced exploration devices to search for subsurface water lakes beneath Europa's icy surface, measuring the depth and salinity of the subsurface ocean. This will be the first time scientists can directly study the environment inside this moon. Initially, NASA planned to use the Space Launch System, SLS, for this mission. In theory, this was a reasonable choice as it would provide additional missions for the new SLS rocket. Moreover, the SLS is capable of delivering Europa Clipper to Jupiter within less than 4 years. However, around 2021, several factors led NASA to change its decision. First, switching to SpaceX's Falcon Heavy would significantly save costs for NASA. The estimated cost per SLS launch exceeds $2 billion. In contrast, using commercial rockets like Falcon Heavy could save over $1.5 billion. The U.S. government requested Congress to grant NASA flexibility to use commercial launch vehicles instead of SLS. Finally, the cost-saving efforts were successful. SpaceX was chosen to launch Europa Clipper at a cost of only $178 million, a remarkably low figure compared to the $2 billion saved by switching rockets. In addition to cost concerns, NASA is also worried about the readiness of the SLS rocket. Whether SLS can launch Europa Clipper by 2024 is a big question mark. Although the SLS rocket is capable of delivering Europa Clipper to Jupiter about 1.5 years faster, this advantage is easily overshadowed by time risks. NASA is concerned that the primary contractor for SLS, Boeing, may not produce additional rocket cores for this launch in time, potentially causing mission delays. More importantly, NASA decided to focus SLS resources on missions to return humans to the moon. Additionally, the strong vibrations of the SLS during launch are also a concern for Europa Clipper. This could damage the sensitive scientific instruments aboard Europa Clipper. To address the vibration issue, NASA would have to redesign Europa Clipper, estimated to cost an additional $1 billion. Thus, switching to Falcon Heavy has saved NASA a total of about $3 billion. Moreover, Falcon Heavy has demonstrated reliability through a series of successful missions. While Europa Clipper is in the final stages of preparation for its historic launch, the Falcon Heavy rocket is still busy with other important missions. Ahead of Europa Clipper, the next notable mission for Falcon Heavy is to launch the GOES-U satellite by the end of 2024. This will be the first Falcon Heavy launch of the year, following the success of its mission in December last year. Looking at the complex structure of Europa Clipper, we can understand why this mission requires so much time and resources. Jupiter's moon Europa lies deep within the harsh radiation environment of Jupiter. Even spacecraft designed to withstand radiation only operate for a few months. Another major challenge is the data collection speed of scientific instruments, which often exceeds the transmission capability of the communication system. The number of antennas on Earth capable of receiving scientific data is limited. Therefore, data transmission time to Earth is a key factor affecting research efficiency. However, scientists at the Jet Propulsion Laboratory have found a solution. Instead of spending time orbiting Europa, scientists plan to execute multiple flybys of Europa. Research shows that this method optimizes the time for valuable scientific data collection. Typically, in other missions, Falcon Heavy would save some fuel for the return journey to Earth, allowing the rocket stages to be reused. However, the Europa Clipper mission is a special case. To provide maximum thrust for Europa Clipper, NASA will utilize all the fuel onboard Falcon Heavy. This means that the 3 rocket stages will not be reusable and will instead fall into the ocean after completing the mission. This all-out decision is necessary to propel Europa Clipper into the desired orbit, officially initiating a promising exploration journey. The maximum thrust of Falcon Heavy will help Europa Clipper reach speeds of 40,200 km per hour relative to Earth and up to 129,000 km per hour relative to the Sun. However, it will not be until April 2030 that Europa Clipper can enter Jupiter's system. Over the next nearly 1 year, the spacecraft will fly around Jupiter and utilize the gravitational pulls of the other 3 large moons, Ganymede, Callisto, Io, to adjust its trajectory, aiming for Europa in 2031. Scientists believe that Europa Clipper can operate for more than 3 years at least. NASA often sets lower than actual expected operating times to manage expectations and create surprises when spacecraft exceed targets. For example, the Spirit and Opportunity rovers on Mars were initially expected to operate for a minimum of 90 days. But ultimately, Spirit operated for 6 years, while Opportunity lasted for 15 years. Europa Clipper is also designed to have a similar lifespan. The main body of Europa Clipper is 5 meters tall, but when the giant solar panels are deployed, it will extend to 30 meters, equivalent to a basketball. The spacecraft is equipped with 24 engines for navigating through the obstacles, Jupiter's moons, enabling precise approaches to Europa. Europa Clipper carries 9 state-of-the-art scientific instruments, including high and low-resolution cameras, a thermal mapping system, a mass spectrometer to study the chemical composition of Europa's surface and thin atmosphere, gravity sensors to measure Europa's deformation as it moves on its orbit, magnetic field detectors, and other tools to determine the depth and salinity of the subsurface ocean. Whether Europa Clipper finds evidence of life or not, according to the Culberson Law enacted in 2015, NASA still has to carry out a landing mission on Europa in the future. However, this will not happen soon. NASA conducts decadal surveys to select missions for the next 10 years. The next assessment is scheduled for 2030, just when Europa Clipper arrives at Jupiter. Planning, designing, and building a lander could take another decade. Thank you for watching the video. Let's look forward to the next grand events together. Leave your comments about today's broadcast. Don't forget to like, share the video, and subscribe to the channel to stay updated with interesting information. Goodbye and see you in the next video.